Hi guys, so in this video we're going to solve challenge 5. So in part A we're asked to state Hooke's law. So anytime we're asked to state a law or an equation, the first thing we do is check our log tables to see if we have an equation for it. So Hooke's law states that F is equal to minus Ks, where F is equal to the force, K is your spring constant, and S is your displacement. Okay, let's look at the rest of the question. An elastic constant of a spring is 12 Newton meters, and it has a length of 25 millimeters. An object of 20 grams is attached to the mass. Find the new length of the string. Okay, so the first thing we're going to do is write out what we know. We're told that K, or spring constant, is 12 newtons per meter. And we're told that it has a length of 25 millimeters. So immediately I'm going to change this value into meters, so that's 0.025. Okay, so here we're looking for the new length of the spring. We're also told that the mass is equal to 20 grams. Again, immediately you need to change this value into kg. And to do this, we divide it by 1,000. This gives us 0.02 kg. Okay, if we want to find the length of the spring, let's draw a diagram of what we have. So we have a string that was 0.025 meters. And due to the weight being added on, so due to this applied force, the spring has been extended, and we want to know what is the new length. To find this new length, we're going to use Hooke's law to solve for the extension and then add it on to the original length. Hooke's law states that the force is equal to minus Ks. Note how the question tries to lead you in these. We're looking for our displacement. So we know what K is, we're looking for S, and we need to find F, the force. The force in this case is the weight that is applied to the spring to pull it down. So our force here is the weight of the mass. So the weight of the mass is equal to minus Ks. To find the weight of the mass, it's the mass times gravity. This gives us 0.02 times 9.8 is equal to minus 12 times S, or displacement. And from here we just need to solve for S. Let's multiply out what we have. 0.02 times 9.8 gives me 0.196. This is equal to minus 12S. To find the S on its own, we divide both sides by the value that's attached. So we're dividing both sides by minus S. Note in these questions, it doesn't matter if you keep in the negative sign or not. This is simply telling you the direction of the displacement. Dividing our value by minus 12 gives us a displacement of 0.0163. Okay, so this displacement is our extension. We're asked in the question for the new length of the spring. The new length is equal to the original length plus the extension. This gives us 0.025 plus 0.0163. Adding these together, our displacement is equal to 0.041 meters. That's rounding it to two significant figures. Okay, let's look at the next question. We're told that the object is pulled down until the spring length is increased by a further 5 millimeters. The object oscillates with simple harmonic motion. We want to sketch a velocity time graph of the motion. When an object is moving in simple harmonic motion, it executes a trigonometric function. This is a periodic motion. We'll place time on the x-axis and the velocity on the y-axis. Time is measured in seconds, and the velocity is in meters per second. At a time of 0, we have no velocity. So our graph starts at 0, 0. This forms a sine curve with a repetitive motion. Okay, let's look at the next question. Calculate the period of the oscillation. So now we want to find the period of the oscillation. Let's draw out what we know so far. We know that the spring has been extended by a further 5 millimeters from the place where it sits with the weight, which is 0.041 meters. And we know that it oscillates up and down about this point. The first thing I can do is change my extension due to simple harmonic motion from millimeters into meters. To do this, we divide our millimeters by 1,000. Okay, so we have our object which is sitting at its extended Hooke's law length of 0.041 millimeters. And then it bobs up and down about this point. We want to find the period. This is what we know so far. We know the displacement is 0.005. All right, let's try and figure out an equation for the period. To find the period, we know that the period is equal to 2 pi divided by our angular velocity. So before we can find the period of the equation, the period of the motion, we need to find our angular velocity. Our object is executing Hooke's law, so to find our angular velocity, we use our equation angular velocity squared is equal to k over m. This tells us that angular velocity squared is equal to k, which we find at the start of the question, and our mass, which we're also told at the start of the question. Our angular velocity squared is equal to 12 divided by 0.02. This gives us our angular velocity squared as 600. To find our angular velocity, I square root both sides of my equation. My angular velocity is equal to 24.495 rads per second. Okay, now that I find my angular velocity, I can go ahead and find my period. The period is equal to 2 pi divided by my angular velocity of 24.495. Using the answer button in my calculator, I write in 2 pi divided by answer, and I get my period as 0.257 seconds, and rounding to 2 decimal places gives me 0.26 seconds.